Welcome everyone, and thank you for joining us on our 21st YPIC webinar. Which is today sponsored by Biognosis Group, and today we will dive in how we can navigate AI in science and the responsibility, integrity, and scientific practice that comes with it. And so to talk about this today, we are very happy to be joined by Dr. Sebastian Porsdam Mann, who is an assistant professor of law at the University of Copenhagen, and whose works include investigating ethical and legal implication of AI in academic contexts. But just before diving in, I would like to update you on YPIC upcoming events. So first, we would like to inform you that all available spots for attending the annual Proteomic gathering in Madrid on the 16th of April have been now filled. However, the registration form is still open for those who would like to sign up for the waiting list. So in case of any cancellation, we will contact participants on the waiting list, and therefore you might still be able to join us. Then I also invite you to join us at the European ECR in Proteomics online event on the 23rd of April. There you will be able to meet 2024 YPA ECR awardees, but also if you want to participate in the 4th edition of the European Proteomics Science Slam, you are very welcome to register for that also. And it's also an opportunity for ECR to network together through Proteopolis. So please, if you are interested, the registration is free, but you need to be registered to participate. So you can use the QR code that is here on this slide. And finally, you can add to your calendars, if it's not done already, the next YPA Congress, which will take place in Würzburg, Germany, in November. And there you will have many events organized by the YPIC, such as Educational Day, ECR Highlight Session. So please, if you want to join us there, we'll be happy to see you there. And so now I would like to give the floor to the Biognosis Group and Sierra, who is with us today, Biognosis, who is sponsoring our webinar series. So thank you very much for being here today. And the floor is yours, Sierra. I will stop sharing here.
Hello, everybody. I'm sharing my screen now. Okay, so I hope everybody see my screen. So good afternoon, everybody. And I want to thank the YPIC organization for giving me the opportunity to present ourselves today during this webinar. I also want to acknowledge the YPIC role in promoting networking and building community among the young scientists in proteomics, and also supporting them in aspects that are very important for a scientific career, but they are normally not part of a formal training. These are things like writing impactful science, abstracts, how to present a poster, and something that I particularly like is breaking that concern of moving away from the comfort zone of academia. Among other aspects, I think these are skills that help scientists to evolve not only technically, but also to become good collaborators, good communicators, and ultimately become leaders in the scientific community. We believe these initiatives are very important, and that is why we are very happy to support them. And with this, I would like to present the organization that I am representing here. So I'm not sure how many of these companies that I list here are you familiar with. Probably, actually, I am showing the last slide and not the first one. So let me move that. Okay, I'm going to stop the presentation. And start again. Sorry about that. Here we are. Okay, so as I was saying, I don't know how many of these companies are familiar to you with proteomics audience. Probably Biognosis and Preomics rings a bell. Biocrates was doing and is doing metabolomics, and the message that I want to convey here is that these three companies are coming together to create the Biognosis Group. And the Biognosis Group has as a mission to provide solutions to go from sample to insight. And we do that by offering an integrated ecosystem of consumables, software, instruments, and also CRO services. And an aspect that we strive is to be vendor neutral. And that means our applications and our solutions are compatible across all major mass spectrometry platforms. So our portfolio of solutions is very wide. We offer solutions for sample preparation, from homogenization of samples for proteomics to dedicated sample preparation kits for different sample types. We also have a very highly performing biofluid profiling platform with probably the best particles for plasma enrichment, as well as dedicated sample preparation kits for that. We also offer quantitative kits, quantitative assays, both for metabolomics and proteomics. We have kits for metabolomics that are capable of quantifying and analyzing over 1,000 metabolites. We also have a quantitative proteomics kits for proteomics, in this case, plasma, and we also have kits for QC purposes, like the IRT kit, which maybe are familiar with you as well. We also offer right now PEP-SEP LC columns and other consumables around MALDI and other consumables in general. And we are developers of software for analyzing proteomics and metabolomics data. And related to the topic of this webinar, AI is something that is really in our DNA. When we developed software, we saw the potential of AI very early on, and we even have a dedicated team for that. And AI is something that is significantly integrated in our algorithms and the way we become more sensitive. We also offer, for those who don't have access to a mass spectrometry facility or lack the resources or the expertise, if you want a hands-off experience, we also offer CRO services with very good experts in proteomics and metabolomics. And I don't have a lot of time to talk about all of those things, but I wanted to highlight something that is maybe relevant for proteomics community, which is our portfolio of software solutions. As I mentioned, we develop software for proteomics and metabolomics. I am highlighting here the ones for proteomics. Maybe Spectronaut rings a bell to you. It's our software for analyzing proteomics data acquired in DIA mode. We also have a dedicated software for targeted proteomics and another one for acquisition in DDA mode. And our latest launch is a solution, it's called Omics Flow, is a solution to optimize the way our search engines, the ones you saw before, how they run in a cloud environment. So as proteomics is becoming more data rich and experiments have becoming more and more large scale, we saw that there is a need to provide solutions for speed and scalability. And Omics Flow does that in a cloud environment. So Omics Flow is orchestrating and monitoring the jobs that run a Spectronaut to get the most out of your cloud, and it's plug and play. So this is our latest advance, and if you are interested, please reach out to me. And that is all I wanted to say. Thank you again for giving me this opportunity. Please reach out to me directly if you are interested or you have questions. And thanks for organizing this very interesting webinar. And have a good webinar otherwise.
Thank you very much, Kira, for joining us today. And thank you again to the Biognosis Group for sponsoring this webinar series. Now we'll give the floor to today's speaker. So just before doing that, I want to remind everyone of how we will be working for the question you should have received when you connected to the link, Slido invitation. So you can join in the Slido, or you can write down your question all throughout the presentation. They will be anonymous. And then at the end, we will ask all of them. And also, if you have question that you find interesting, you can vote for them. So we will ask them in priority at the end of the presentation. So now, Sebastian, the floor is yours. We can see your slides.
Okay. All right. Well, thank you so much for the lovely introduction, the invitation to be here, and the interest in my work. So, I actually have a soft spot for proteomics, having worked a few years ago on the ethics of proteomics, but that's not what I'll be telling you about today. So, when ChatGPT came out, I sort of got extremely fascinated with this and dropped everything I was doing and sort of realized that if I don't start working on this, I might get run over. So I've been since then working on both practical stuff, what you can do with AI, and also what you should do with AI. So we hopefully avoid a situation like in this meme that some of you might have seen. But you don't need to be a specialist in AI to know that things are going really, really fast. And so here's a overlay of a semi-famous graph that was in a MIT study from mid or late last year, where they sort of look at how fast performance on complex tasks increases. And on the x-axis, you have the year, right? And then on the y-axis, you have how long a task takes a human to do, which the AI can do successfully 50% of the time in one shot. So basically a measure of complexity. And I've sort of overlaid here, this is subjective, but my sort of understanding, as well as that of many colleagues I've spoken to, of roughly the level, cognitive level that these models are working at. And interestingly, this is, if anything, this is increasing, right? So the rate of progress has increased since then. For those that haven't seen this yet, Sakana.ai claims to have had the first fully automated paper released in March 2025. Um, so maybe some of you have tried AI systems, LLM systems a while ago, and then didn't really think it was, maybe it was, fun to create Shakespearean sonnets or whatever with it, but you didn't think maybe this is good enough for my work. But since then, there's been a lot of progress in what these models can do. And so I normally present this stuff for a humanities and social sciences context. I'll assume that there's a bit more background knowledge here, but just very quickly, now it's possible for models to start reasoning, to draw on curated knowledge bases, to use tools that let them retrieve information online or in curated knowledge bases, to talk to other AIs, and to basically do a lot more advanced stuff than was possible even a year or two ago. Some of this is relatively straightforward. So now some models will break down tasks into pieces and sort of take things step by step, just as humans do when we reason. But I consider it to be more relevant for ethics and for practical use. These, I mean, not that that's not relevant, but even more so here, the ability to draw on live web search, to use retrieval augmented generation, which is sort of a vector search in a curated database, to ground its answers in information that's been collated for the purpose rather than just retrieving whatever it finds randomly from its parametric memory, from its pre-training, or the first thing that shows up on Google. And this enables sort of some of the more interesting use cases I'll talk about in a minute. I'll also be talking about fine-tuning. So this is, whereas the retrieval augmented generation I just mentioned is a existing model that then goes outside and retrieves information, brings it back to its context, uses that to reason through and answer a question. Fine-tuning is if you take this curated knowledge base, this additional training set, then you change the model with it. So instead of running the whole training again, which is very, very expensive and takes a long time, what you do instead is you take just the sort of top few layers of neurons and you give them additional training on this specialized data set What that does is it means that the model retains its sort of underlying understanding of language and whatever else is bound up in it, but gets additional specialization in the specific features of this new data set. So one can think of it as like getting a master's degree or a PhD on top of a liberal arts education. Most importantly is this multi-agent system where there are various protocols and various technical setups that now enable one language model to talk to another instance of itself, famously in systems such as Claude Code or OpenAI's Agent SDK. But in theory, through model context protocols and other ways, any language model can now talk to any other language model, and you can have these recursive systems that iterate on top of each other. And this enables some more interesting scientific and ethically interesting use cases. And something I'll be talking about, like a red thread that'll be running through the next sort of 30 minutes, is that you can use all these different tools and techniques to take a basic language model, foundation model, off-the-shelf model, what have you, and use these various advanced things on it and turn it into a specialized language model. And so when this is on the basis of information that's unique to one person, as I'll tell you about later, for example, with training a system on all my own writings, we call this a personalized language model. So a model that's been adapted to a person to either emulate them, represent them, or respond in a more individualized manner according to the preferences and background of that individual. And if we're not talking about an individual, but we're talking about groups or specific applications, we call it application-specific language model. Now, I first got interested in this back in early 2023. So when ChatGPT came out, so my friends and I thought we'd be clever and we thought we'd write a paper about ChatGPT with ChatGPT. And we thought that was very smart, but lo and behold, of course, it wasn't. And everybody else did that too. And at any rate, it turned out that our first draft wasn't, super good. It would have been a great high school essay. It would have done fine at undergrad, but there was no way it was getting into any good journal. So, but I got a feeling playing around with it, like sometimes it would come up with really, really good stuff. So I was like, how much of this is just user error, right? How much of this is just me not knowing what these systems can do if trained, if used correctly? So I started reading around and I came up with this, or I heard about this thing called fine-tuning that I briefly pre-demoed before. And this is like an old thing, right? This has been around since the 80s, I think. It's very standard in machine learning, but for language models and for the kinds of things that I was thinking about, it was new. So to me, so the first thing that came to my mind was, look, this I'm getting some output from the model, and then I'm changing it to sound more like me. So why don't I just give it all the stuff I've ever written? And now I'm junior, and I was even more junior then. But I have senior colleagues who have written hundreds of papers, right? So what if we get those guys on board? I write with them anyway, right? And then let's train a series of models on these papers. And the way that works is you take your papers, you split them into this standardized format. These days you can do that with the LLM. Back then we had to use knuckle-fat and research assistants. What fine-tuning requires is like a list of example inputs and a list of example outputs that you want. So we took our papers and we said, this is the output. Context window was smaller back then, so we just do section by section. So we'd have like introduction would be one row, background would be the next row, and so on. And then for the desired input, we thought we needed some kind of description of the content of the paper. And luckily, right after a few days of messing around, we thought, well, we have it, right? It's the abstract, it's the title. So we put like some pre-prompt, like giving it a role, giving it a task, and then the title and the abstract, and then based on this information, write the introduction, and then next row, based on this information, write the background, so on. And that gives us a database, right? Or just an Excel sheet, which you turn into a JSON-L format. You send this. In our case, we used OpenAI's backend for this. Like they just have on their platform, you can just create an account and upload this data set, and you don't have to really do anything yourself beyond specifying a few parameters. And then we get this personalized model. And this actually worked pretty well. So we did this back with GPT 3.5 back in the day. And just visually, I mean, you don't have to read all of this, but you can see on the left-hand side is the base model. On the right-hand side, it's just, there's more of it. It reads better. And in general, it looks more like what my senior collaborator, Julian Sablescu, in this case, would write than the GPT itself. So that got me interested, and then I sort of thought, what else can we do? So I would then, when I was working with this, when I was trying to get it to create paper drafts, I'd find that it was highly variable, right? So sometimes it would give stuff that was as good, and sometimes even stuff that was better than what I could write myself, or even what my colleagues could write. But sometimes it would be horrible. It would trail off, it would be nonsense, and often it would degrade. So what I found myself doing was like generating multiple versions. And it's not really a problem here because it's so fast. You can just hit refresh. And at some point I thought, oh, we can automate that, right? Found myself always making at least 5 drafts. So what if I just write a script that calls this model? And then this idea of a paper writing workflow or paper flow was born. So the very first version here that I'm going to show you involves just a very simple, we use the Streamlit UI. It pops up, it asks you to put in the title, the abstract, and the section headings for what you want to write. Then goes to the AutoGen, which is what we call the fine-tuned model I was just talking about, the one that was trained on our previous papers. Creates 5 raw drafts. This gets passed back to a general LLM, so not a fine-tuned LLM. We use always the most recent version of Anthropic's Claude because in our experience, it's the best at prose specifically, and it has custom instructions to look through these 5 drafts, take the best parts of each, piece it together. It then gets sent to a different model. So here we use whatever is the most recent GPT model, and it has then a task, a pre-specified task, to use these tools and this reasoning that I talked about in the start to go out and get relevant information about this paper, right? Because like at the stage 3 here, you do have citations, but they're hallucinated, they're made up. Some of them are real, right? But some of them are not. You can't really rely on that. So in stage 4, the model reads the paper and goes out and finds relevant information, does a research report. This gets sent back to Claude, and it integrates it, and then you have your first draft. So this is what it looks like in practice. So this is like an early beta. And so here what we're doing is I'm using a specific use case for this setup that I call rapid prototyping. So I get some idea and I just type a 2-sentence version of this idea into GPT-4o. This is a year and a half ago now. It comes up with a title, an abstract. I just plug this in. And the idea here is like, if you're like me, you sometimes will have like what you think is a good idea and you'll write it down like in a note or whatever, or in your iPhone. You'll forget all about it. And 2 weeks later, you'll see it and you'll be like, what the hell is this? I have no idea what this means anymore. And so with the system, the idea is to have a rapid prototype, just like you might do in engineering or in design. And then while it might not be perfect, you have something that is pretty close, and at least is enough to jog your memory when you then come back. And this can be of arbitrary length, right? So we have a drop-down menu or like a free text entry for how many sections you want, but you can do this as long as it's short as you want. Then, as I said, this was an early version, so I sort of got interested in this, and I thought, okay, there's still very rough and ready. Can we do this a bit more? Can we do this a bit better? So some of you might have heard of this thing called N8N, which is basically a no-code or like low-code visual programming platform that lets you create like little nodes, and it's kind of like Lego. You put the pieces together, or like maybe like a mind map is a better analogy. But here, each node does something, right? It's like a piece of code, or it's an LLM or an agent or whatever. And so here, there's an input right in the start, and it pops up, and you put in that same information. It then goes and does a bunch of research. It's a bit more sophisticated here. It has access through something known as MCP. So it pulls information directly from academic databases, from like PubMed and Archive and stuff, and it doesn't just go on the vanilla web. Although here there's a deep research external call to GPT's deep research function, which does look at the general vanilla web. And this is sort of all fed together into the specialized model, and then we have a whole setup to handle citations because it proved to be a pain to have to propagate correct citation information. And then there is a fact-checking agent and a style agent at the end. So the details are not super important. It's just to show what's sort of possible, even for a rank amateur with no coding experience like me to do. So everything I'm showing you is vibe coded, but it works. Generally, sort of we have this evolution from single prompt through these slightly more sophisticated or more involved, more automated systems. And now I'm going to show you what we're working with now. So this was all previous stuff, and now we're working with multi-agent systems in Claude Code. So we have a agent that specializes in research that has access to these academic APIs. We have a citation manager that uses Zotero, so it takes the DOI and resolves it and pulls the correct information from Zotero. So the model's not responsible for the citation itself. There's a fine-tuned model that does the drafting in my own voice. We have a critic subsystem that calls 3 different LLMs and gets their peer review, right, with like very detailed instructions for how to do the peer review from different disciplinary angles. This all gets fed into a revisor, and then there's a final touch agent that does a cover letter and abstracts and figures using Nano Banana. It calls this image generator from Gemini, which, by the way, is also the model I use to create most of these slides, full disclosure. This lays out the steps. This is basically what I just told you. I'm going a bit faster here than usual to try to cover a bit more ground, but we can come back to any specific detail in the question and answer at the end. And we use Claude Code for this. So this is what it actually looks like. For those that don't know, Claude Code is a command line interface. So it's an LLM that lives in your terminal, right? And so if you're not capable of doing everything with bash commands through the terminal yourself, you just talk to it in natural language. I use speech to text. I literally just talk to it. And it's then in natural language, right? And it then translates that into terminal code and runs stuff. And then it tells me what I'm doing or what it's doing. I can stop it at any point. And to make this work, it's very important that you get it to plan ahead. So on the left-hand side, you see plan mode. And like, if you use any of these tools, you got to pay a lot more attention to the plan than to the subsequent process. Because if you get the plan right, it's just going to go and do those things like while you go to the gym or while you have a nap or whatever, and you come back, let's follow the plan. But if the plan's shit, then the outcome will also be bad. And that's what we're currently using. It's endlessly flexible. It's very performing at a very high standard. Good. So that's the theory. Now for some use cases. So I kept the slide in. This is from a presentation I gave at the National Ethics Committee here in Denmark. And what was relevant to their use cases was application-specific language model for clinical trials. So the idea here is regulators are sitting on a lot of relevant information on which trials get approved and which don't. And that data is useful to train one of these application-specific models. And so the idea is this would be made available both to the regulators, but also to the individual researchers to make sure that the applications are, so that you can pre-screen it yourself before submitting. And we have another paper, same idea for IRB or ethics review, which is one of the main bottlenecks in scientific research, as I'm sure I don't need to tell you guys. For anyone that's interested, here's a QR code to those papers, as well as to a news feature in Science that ran like half a year ago or something. We also have a few other use cases for this. So going from the top left, we have if you train it on everything, all the data relevant to yourself, you have a sort of virtual instantiation of yourself, an AI simulation of your individual mind, an AI sim, digital doppelganger. People have lots of different names for this concept. And in the first paper, we sort of ask, is it relevant to maybe finishing some projects that you might have? So the idea here is, Why do people want lifespan extension? Well, for like 90% of it for sure is continued subjective experience, but there is still something that's like maybe you're George R. R. Martin and you want to finish your epic fantasy book still after you die, or maybe you have young kids and you wanted to be able to impart advice or whatever. And so we argued that once this technology matures, you can use it for finishing some of your legacy projects after your death. Perhaps more germane is the second idea here, where if people lose capacity and somebody has and there's something wrong with them, then somebody else has to make decisions for them in a clinical context. And unfortunately, like all the research shows that next of kin is just terrible at this. Like people just have no idea what their loved ones want. It's like barely above chance in all the studies. Plus, it's really tough for people, right? So there's a lot of trauma, a lot of PTSD. It's not an easy decision to pull the plug, as it were, right? So what if you could train a personalized language model on people's, conversations, people, whatever data is authorized, either by themselves pre-mortem or pre-incapacity, or by the family, the next of kin, or whoever the proxy decision maker is. And we've actually tested this in beta, and it's quite accurate. I even used it and had to revise some of my own things that I thought I knew about my medical preferences. This last one here is part of personalized consent. So it will take too long to explain in detail, but the idea is you mint an NFT that's associated with a sample. That NFT has the metadata for the sample. And when it gets passed along in a biobank or between different labs, whatever is done, whatever is entered in the LIMS system is automatically also updated in the NFT. And all this sort of study-specific information is made available in an online dynamic consent platform. And then this AI sort of explains it to you in whatever way you want, taking as long as you need, so that you understand what your donated materials are actually doing and what they're actually contributing to. Peer review is obvious, and the last two are, I think I'll skip them for time. But point being, there's lots and lots of different applications for this kind of idea of modulating, modifying base LLMs based on personal data or application-specific data. Good. Now, you weren't expecting all of that. You were expecting some ethics. So here it is. When our very first paper we wrote on this was in collaboration with Sven Nyholm and John Danaher, who are philosophers of technology and AI ethicists, and they have this pre-existing work on credit and blame. And basically, the key sort of idea here is that for someone to deserve praise for an action, and in this case, quite obviously writing a paper with AI, for someone to deserve credit for writing a paper, they have to have some effort, skill, creativity, and ideally they would have had to sacrifice something, even if that's just opportunity cost. And generally they must, do something to deserve the praise. But interestingly, the other way around doesn't hold, right? So for someone to deserve blame, negative credit, you either have to do something bad, but you can also just be negligent or reckless. And so what does this have to do with AI? Well, when you use AI, or at least the perception is that it diminishes your effort, skill, creativity, and sacrifice that you put into doing something. And so you deserve less credit. And we have empirical data on this. I'll show you in a second. But the same doesn't hold for being held responsible for negative stuff. So you get this credit blame asymmetry, where if you use AI, you are liable to get less credit for your hard work, but your ass is still on the line if something goes wrong, right? So the standards for blame remain the same, and it's harder to get credit. And we showed this, so I'll spare you the details here. And what we then sort of find is that, interestingly, so this is the credit blame asymmetry itself. So the red is the harmful condition where somebody's done something and they used an AI and it's messed up, and now somebody is to blame. They get all the blame, or like 80, 90% plus, but they don't get all the credit when when it does something good, right? When the blog post they write helps cure cancer or whatever it might be. And here it's actually this gap is ameliorated by this personalized. So if you use an LLM that's trained on your own previous writings, you get more credit in lay people judgment, presumably because it's based on your own prior effort, skill, originality, and so on that you put in, demonstrably had to put in order to train this model. And this replicates in different countries. There's some interesting country level differences, but that is too much detail for right now. And we did the same in art, and you see the same for artworks. Okay. Now another interesting ethical issue here is what we call the provenance problem. So the idea here is, let's say that you're using one of these systems to help you think through a paper idea before you write it. Maybe you're putting in some data and you're asking it to help you interpret it. Maybe you're putting in an argument and you're saying, does this hold up? Has this been done before? And what then you might get is like you put in some underspecified idea or like, here's my vague interpretation of the data. It then spits out, the model spits out, the system spits out a really sophisticated version of what you just said. And you're like, oh yeah, clearly that's what I thought. That's what I meant to say. It was this is exactly right. And I just used the AI to spell it out. But unbeknownst to you, actually, the reason why it was able to give this gloss on your half-formed idea and to bake it fully is because of some unknown paper, like forgotten paper, Smith 1975, we call it in our little correspondence piece here, which is not, directly influencing it, but it occurred maybe 15 times in the training data, enough to change the statistical sampling distribution so that the next likely token in the sequence is somewhere between your idea and Smith's idea. And what you get here is the so-called provenance problem, because nobody's doing anything wrong here, right? So you're not stealing Smith's idea. You have no idea that Smith existed. The LLM's not, it's not conscious. It's not doing anything on purpose. And Smith is long gone, and there's no citation to Smith's work. So you have this like situation where you're benefiting from previous people's work and you're not citing it. Now, of course, as a lot of people pointed out to us on LinkedIn after we published this happens in humans too. But it's interesting and it connects to this credit thing I just showed you. So how are we meant to deal with all of this? And so we have this paper also like a while ago now, where we argue that actually there are the sort of existing principles that we have in science can just be adapted and used for LLMs. Now that's a big claim. Let me unpack it. What do I mean by that? So if you look, for example, at the authorship criteria from the ICMGE, the International Committee of Medical Journal Editors, it's this like you have to have you have to be able to take responsibility for, you have to guarantee your work. Everybody that's on the paper has to have made a substantial contribution. They have to, everybody has to read and, sign off on the paper and so on. And there are some existing open science principles, for example, that govern what we put in our method sections about other tool use, right? So you got to put enough information that the paper is hopefully not only understandable and evaluable, but also reproducible. And what we did in this paper is to say, look, a lot of people have a lot of criticisms of LLMs, but when it boils down to it, if these things can make our work better, faster, if it can increase the product of quantity times quality, then there is a pro tanto moral reason. And pro tanto is like Latin for as far as it goes, right? There's a reason as far as that reason goes to use them, right? There's like a defeasible obligation to do anything that helps you get more good science out there to the extent that you're publicly funded and that you adhere to these professional duties through that. And so there's no like overall reason to fear LLMs as long as they're used in a way that enhances the quality and the quantity of your work. But that's a big if, right? And so we said, well, there are these existing principles from open science and from the ICMGE that we can adapt. So we say if you do this, it's by and large ethical to use these models. So one, like whatever comes out, you have to go through it and you have to be able to endorse it. You have to guarantee the accuracy of it, at least to the same standard that you would if you had written it yourself or if it had come from a collaborator. In other words, if you publish it and your name's on it, your ass is on the line. If something goes wrong, you have to take responsibility for it. You can't just blame it on the LLM. Substantial contribution is the same as from the ICMGE criteria. Adapted here, though, in the paper, because it's also possible to make a substantial contribution through the use of LLM, right? If you have spent thousands of hours creating these systems I showed you, if you have if you have practical skill in how to prompt well, if you gather the data that's needed to fine tune the model, whatever. These are sort of new ways to make a substantial contribution, but it doesn't change the fact that you shouldn't put your name on the paper unless you did something to contribute to it. In the paper, we have transparency, right? So transparency is a big buzzword in AI ethics. But we have to remember it's not transparency for transparency's sake, right? We don't require each other to give the full record of every lunch conversation and every email that they had with people before coming up with this idea, and then every single Google search you did to find the relevant methods and so on. Like we sort of trust people, and also it would be counterproductive to require this, right? It would be a lot of extra effort for not very much extra benefit. And that's regulated by these well-known open science principles that presumably all of us have heard of. And so again, they apply here to LLMs. So if you use an LLM in a way that doesn't affect the methodology or the reproducibility or the evaluability of the paper, there's no good reason to declare it. But if you use it in the methods, or if you use it to interpret the results, or if it is in any way relevant to other people being able to understand what you did and reproduce it, then you have to declare it to the same extent that you would, or in the same way that you would, which statistical tests you used and which package you used for that, and so on and so forth. Now, finally, this is not in the paper, but this is just sort of a general thing is this idea of putting some of yourself and your own prior work into your models, into your systems to increase the connection, right, between yourself and the model's output on the theory of credit and blame from before. Okay, so that's a whirlwind tour of that. Generally, what does this all come down to? So the best sort of analogy that I find in my work is that when we use these sort of systems, we all become PIs or lab heads or senior authors to some extent. What do I mean by that? Well, if you're a big dog, you have funding, you have a lot of people working for you, you get some idea, and you get your postdoc, your PhD student in the room, and you say, well, here's an outline, and here's the methods I want you to use, and go out, come back in 6 weeks with a draft or with data, and then we talk again. And this happens any number of times until there is a paper draft. That then gets edited, there's like supervision and feedback from the PI, and eventually you end up with a paper. And this is, in our estimation, I should have put the paper up here. This is Hirschman et al. 2026, in case anybody's interested, archive preprint. This is structurally, philosophically similar, if not identical, to what it's like to delegate tasks to LLMs. And so we have the existing models for that. We have the existing understanding of what's appropriate and what's inappropriate there. You don't deserve to put your name on the paper if you delegate the whole thing and never look at it once. But if you go through this iterative process, it's a different matter. That's why we have the senior authorship at the end of the paper. And more, as these tools become more powerful and become able to call on other tools and become able to do stuff that they weren't before, more and more people that use this in their workflows will come to resemble a PI over their own AI junior scholars in this case. And this is not just a neat analogy, but it's also relevant ethically, philosophically, because it means that whatever principles and whatever understandings and whatever ethics we have for that relationship can be adapted here. So we're not shooting in the dark, right? That's the idea. And so this is the this is the practical tip version of that. And this analogy I find is actually more instructive on the appropriate use than it looks at first. So, yes, these models can do the work for you. Sometimes they will be brilliant, but in general, you still need to come up with the ideas. You still need to check everything. And generally, you just treat it as you would with an unproven junior collaborator or some junior collaborator who has proven their mettle in terms of executing what you tell them, but maybe aren't super wise and don't have enough context and understanding to improvise on their feet correctly. Most importantly, if you act as the senior author, you're responsible, just like the senior author is. You're still the guarantor of this work. Yeah, this is, there's also, I've been talking about these like heavily automated things, but there's also a lot of iteration that you can do at each step of your workflow to sort of make the process better. So you don't have to, like the LLM for paper writing is like just put in your data and your abstract and be like, write me this paper. It's not only that, right? You can also stress test it. You can ask it, tell me 10 reasons why my idea sucks. You can ask it to look through, stress test it, to give you different angles on it, to give you pushback on it, to act as a pissed off reviewer too, to look online, has this been done before, all these different kind of things. So I highly recommend, if you're interested in this area, to like sort of map out what your own research workflow is, and then see if you like at any one point there where you would have liked to ask your PI or you would have liked to ask your best buddy, but they're not always available, try asking these models. There's different models that are good for different things. It's these days there's a lot of information out there, right, about that. But like Claude's better for academic prose, Claude's better for this no-code multi-agent setup. GPT is good for agent, like freestanding computer use. For example, I use it for submitting my papers online, like the submission portal. That's really annoying. And at my university, we have to do research reporting, right? Like all the stuff we did last year has to go up, so you can use this agent to do it for you, and is good enough to do that now. There's more specialized things that help you with citations and so on, but I wouldn't recommend that yet. Even all the fancy Zotero integration, archive integration, and so on, I still end up with some hallucinations, and all it takes is one to ruin your career. So I still recommend doing everything related to citations yourself. I do all my citations myself, and I check every claim in the galley stage. But the point here is just you can use it in different parts of your workflows, and different models are good for different parts. Here's just a take on, this is a bit of an older slide, but it's more or less still relevant. One thing I haven't mentioned yet is local models. So I've been talking about these large commercial models, but these days, the sort of what's available on the open source front, especially the Chinese models like GLM5, Kimi-K2, and so on, they're very, very good. They're very close to frontier commercial closed system performance. And also the sort of hardware it takes to run them is declining fast. So I mean, I have a M3 Studio here, like a consumer grade. Okay, it's a high end, but it's consumer grade, and it will run like pretty much any local language model. And this is important because then you can use sensitive data without being stuck in EU AI Act compliance, GDPR compliance, and or I mean, you still have to do those things, but it's a lot easier. Also, the optics are better when you explain to people, well, this stuff never leaves the servers. It doesn't go to the USA or wherever the servers might be. It just goes to my backyard or my office in this case. Okay, so that was a lot. I wanted to go through and throw some things at you, and then I hope we can have a discussion. And of course, it goes without saying that this is not a one-man job. This is stuff I do with a lot of wonderful collaborators. And my email is here in case anybody wants to follow up. So thank you.
Thank you very much for the talk. It was very interesting, and also thank you very much for the practical tips. I'm sure everyone will appreciate them a lot. There are already questions. which is very good because in my experience, it takes a few minutes for people to type them out and to upvote their favorite questions. So I'm going to give them that time, but I think we can already start with a few. So there's one question that alludes to the earlier part of your presentation about the autogen and using information to create your writing style. Someone is asking, is it ethical to train a model on someone else's data? So take the data from a PI, maybe even if you have personal data from them and data that's not publicly available, do you have to let them know? And are there any legal regulations for that?
Yeah, so excellent question. So there's a few different questions there. So I discuss this a lot with my ethics colleagues, and my own intuition is that you should always ask for consent, that you're just better off. And in my experience, people do consent to this, but I actually had some pushback from this guy called Hazem Zoni at Oxford, a good friend of mine, and he has a response to this Autogen article that you can find on the American Journal of Bioethics website. And in that, he says, well, look, this is published, right? This is what publication means. It's out there. It's fair use. If it's fair use to use this to train GPT to begin with, why wouldn't it be fair use to train a specialized model? And there's a substantial proportion of my colleagues that agree with that. So I'd say you're probably better off with consent, but you probably won't get shot if you do it still. In terms of regulations and stuff, right? So if you use anything that's personal information, then GDPR catches, and I shouldn't talk about the UAI Act because I don't know so much about it, but potentially that bites too, although there's a scientific research exemption for both. But you're generally better off not taking people's emails and putting it in there, right? Like I'd say generally in my experience, people always consent to the use of this stuff. I think they should. It's for science, right? But you can probably get away with using any publicly available information, even if they don't consent. But do ask for consent.
All right, thank you. So, about the second part of your talk, you showed some really interesting examples of how we can use AI also in medicine. Can you think of any use cases in which you would say, no, we should definitely not try to use AI for them?
Yeah, so anything illegal goes without saying. Citations, right? Like it's such an obvious failure mode. Like you have a rival and they don't like you and they look at your stuff and eventually they find the one citation that's went through the system with an issue and your career is over. Or you have to do a lot of explaining for 6 months and you just want to avoid that at all costs. So don't do citations. Sort of what's also a bit is like open source intelligence, right? So these are smart models. So if you start to ask them to figure out personal details about your rivals, it can do a lot with just open source information. And some things it will not do for you, but then you rephrase it, and it's still very easy to jailbreak. So I wouldn't recommend doing that either. Obviously, synthetic data, right, is like only use like so making up data is like only useful for very specific. It's like I have a project where we made synthetic data because we couldn't use the real data because of all the regulations. So we made a synthetic data set and then we could test our methods on that, and that's fine. But clearly, I would not recommend, making up your actual proteomics data for publication with these models, no matter how good you think they are. Um, yeah, I think that's the top
Yeah,
ones.
there was actually also a question about data and making up data and how it's possible. Someone was asking, should there be AI to control if data is made up? Can we control this somehow?
Yes, so I mean, there's all kinds of statistical tests you can do, for example, to tell whether this data is truly random, right? There's some famous things there, and there's a lot of statistical irregularities in made up data. So you can run those statistical tests. I don't see any reason why you wouldn't be able to run those tests using an LLM, right? And in general, something I didn't mention is there's a big difference between putting your data in and asking it to do the analysis itself. That's usually a bad idea. But what you can do is you can be like, here's the data, I want you to write a script. And then I'll run the script myself on the data. Because then, the script will either work or it won't, right? Of course, there are some great cases where you might get something or you're not sure. But by and large, it's black and white whether your script runs or not. And then you know for a fact that there's no hallucinations in there. Another thing I didn't mention is you can control this thing called temperature, which is a setting that essentially controls how creative the response is. So if you break down what an LM actually does, it like is next token prediction, and so a token's a part of a word or a symbol. And for every time that it takes the next token, it creates a probability distribution over all possible tokens, which in the case of GPT is something like 102,000 or something different tokens. And it will then assign a probability to each of them. And it will then sample from this distribution depending on this temperature setting. So if the temperature is high, it's likely to take less like stuff that's lower down on the probability distribution. And if you put the temperature setting very low, like 0.1, it will take always only the top one. There's also other parameters like top P and top K that you can do to constrain what it does with the likelihood of the next token, which then has implications for how accurate it is working with your data.
Oh, that's very interesting. Thanks. Here's a question that you already partially answered, talking about the managing and also the practical tips on authorship. But someone was asking, what is authorship in the age of AI, and how do you think it will change in the future also? Like, what does it mean to be an author now?
Yeah, so this is a very good question. And so I think there's not a fully formed answer to it, but there are certain things we can draw on, right? So first we have to see it's a single concept that does very different work in different fields and for different purposes. So if you go ask the person on the street what's an author is someone that wrote a book themselves. That's what an author is, or maybe a newspaper article. The stuff that predates LLMs, where you have, the seventh author who made coffee and gave a back rub, and they're on the paper. That's like totally alien in terms of normal authorship standards. So my point being that it's a concept that has different meanings in different fields and for different uses. So it's already not so straightforward what an author is, even before LLMs, and now it complicates it further. So how to deal with that? Well, there's two different ways to look at that. One is like, if you look at it from what's fair and what we call process goods in philosophy. So like, is it really fair that somebody who has my system can now make 30 papers a year and you can't? Maybe it's not, maybe it is. That's a long discussion, education and resources. We should make all of this available to everyone so they can use it freely. But perhaps more importantly, there's also what we call outcome goods, right? Which is the actual paper and the cure for cancer, the metaphorical cure for cancer that we're all looking for, or biomarkers and proteomics. And so if the use of these tools and authorship to incentivize the use of these tools, right? So authorship leads to citations leads to H-index leads to promotions and a permanent position. And if there's a non-zero correlation between more papers and more good for the world, then anything that leads to more incentive to produce more papers is good for the world. And so you have to balance this fairness versus the outcome, or in philosophy, we say consequences versus, right, consequentialism versus deontology, rights versus outcomes, right? Which is just a long-winded way to say it all depends, right? Like if authorship with current metrics is the thing that produces the most best science, we stick with that. If it's not, if this all gets broken to shit because of LLMs and because of all the pre-existing pressures, we need to move to some other ideas. And there's one of my colleagues called Sicheng Lin, Lin. He has talked about breaking up the paper to make it machine readable, and I'm also working on with some colleagues on this like sub paper units, right? So the reason we have papers is that when print came out, it's expensive to distribute, so you need to put all the claims and all the context in one piece. Now, already with the internet, that's no longer necessary. Now with LLMs, it's certainly no longer necessary. So you might have these other ways to structure data that are sub article, right? So it might be one claim with the data set, or one claim with 3 citations. And then you could imagine feeding that into like a knowledge graph and then tracing how your input to the knowledge graph gets propagated in the network and then rewarding that. But that's ongoing work, not yet fully thought through.
That's very interesting. Thank you. I think I'll have to cut the questions here in interest of time, but I just wanted to say thank you again. I think as scientists, we all are very happy to try out new things and to just make use of these models if they're of use to us. But all of these questions, it's not really something we usually think about, but I think it's becoming increasingly more important. So I hope that this was very thought-provoking to all of you. And yeah, I'll just give it back to Marie.
Yeah, that's it, I think, for today's webinar. I want to thank you again, Sebastian, and also I think my Gnosis group left, but I want to thank them again and every one of you who joined us today to try to move our brains a bit and things. And it gave a lot of pennies for thought, I think. So thank you again for this, and hope to see you all at our next webinar.
Amazing. Thank you all so much again. And my email was on the slide, and I'm always happy to discuss any of this more via that. So thank you all and have a lovely rest of your Wednesday.
Thank you. Goodbye.